Today we're going to be talking about absolute value inequalities. Okay, we've already spoken a little bit about absolute value and inequalities, so we're going to bring them together today. Okay, one thing to keep in mind that we have from absolute value is remember that absolute value is kind of a way that we represent the distance away from zero. So before, when this was an equation and there was an equal sign there, we were saying that the distance away from 0 was equal to 11. Now what we're saying is that the distance away from 0 is less than 11. So we could draw this, kind of get a look at it. So the 0. We said the distance away is 11, so you could go 11 units that way. That distance right there is 11 units. But at the same time, we could go 11 units this way, and that distance is still 11 units. Okay? Yeah, it's negative, but the actual distance, you still walked 11 steps. So we need a way to represent both of these distances. So we need one for here, to represent the orange distance. And at the same time, we need something else to represent the black distance there. Okay. Well, if you look at the orange distance, we're saying that whatever's in here has to be less than 11. If we're greater than 11, it'd be way out here. So we're looking at things that are less than 11. So I have m plus 2 has to be less than 11. That's what's going to be in this orange distance there. So whatever our m value is, has to be less than 11. We had 2. Now to represent the black distance here, well, I'm looking at that m plus 2. But this time, I need to be greater than negative 11. Because these values are greater than negative 11. If they were less than, they'd be over here. So we'll look at the values that are greater than negative 11. So greater than. And I don't have the equal to because of my original inequality, I didn't have the equal to. And these need to happen at the same time, so this gives us that and situation. Okay, now I can just solve for m. Subtract 2. So m is greater than negative 13. And at the same time, minus 2. So m is greater than negative 13, and m is less than 9. Now we could draw this guy out. Here's 9, negative 13. Remember, there was no equal to, so we have an open circle. We're less than 9, so I'm looking at all this. But at the same time, I'm greater than negative 13, so I'm looking at all this. So the shared portion is our answer there. Okay, the two lines, they meet, fall in love, have a family. There you go. Okay, let's look at another example. Okay, so it's a little bit more complex, so we'll see how we do. Now we have the absolute value of 3 and plus 6 over 2. Minus 4. As with all the videos, I would suggest you pause it for a second and try to do this one yourself, and then come back. Welcome back. Okay, so for this one here, again, we're going to think about that distance away from 0 idea, but we first need to get the absolute value bars by themselves. Okay, we see that they're being divided by 2 and being subtracted, or 4 is being taken away from that. So let's get rid of those first, and then we'll do the idea that we just used. So I first got to get rid of the 4. So I'm going to add 4 to each side. Absolute value of 3n plus 6 divided by 2. Notice that the 2 is outside the absolute value brackets. It's greater than or equal to 6. Now I can multiply each side by 2. 2's factor out to 1. 3n plus 6 absolute value is greater than 12. Okay, so what exactly does this mean? Well, we're saying that the distance away from 0 has to be greater than 12 or equal to. So let's see what that means in a graph. Well, here's 0. 12 units away would be here. But we're saying that distance has to be greater than 12. So now I'm going to be looking at the stuff that's right here. Because those are the values that are greater than 12. Well, remember I could go 12 units this way. This distance here is still 12. And I'm looking for the values that are greater than that. So I'll be looking at these guys here. Okay. So now to represent these, well, I'm looking for the values again that are greater than that 12 unit distance. So 3n plus 6 have to be greater than, and then since it was equal to. And then to represent the orange, again, wants to be greater than 12 units. So these numbers here are less than negative 12. So 3n plus 6 is less than or equal to negative 12. Okay? Now I can solve each of these. Minus 6, minus 6. 3n is greater than or equal to 6. N is greater than or equal to 2. Minus 6. Minus 6 can get a little bit crowded here, but it's okay. 3n is less than or equal to negative 18. When you divide by 3, so n is less than or equal to negative 6. Remember, we don't flip the sign there because 3 was positive. Now we can graph these out. So we have 2, negative 6. And remember, it could be in this one, or it could be in that one. So this gives us that or case. So n is greater than 2, or equal to. So we go that way. N is less than or equal to negative 6. So we go that way. Boom. There you go. Those lines don't meet. So your answer could be anything that's over here, or anything that's over there. Okay? So something good to think about. What exactly does our graph mean at the end? It means that our n values have to be a greater than 2 or less than negative 6 for this to work. Okay, let's look at one more. Again, try to do this one by yourself and see how you do. Okay. Negative 2 times the absolute value of 4x minus 6. We'll say is greater than 18. Okay, so again, we're going to be thinking about this one the same exact way, the distance away from 0. Okay? So what we first want to do, get the absolute value brackets by themselves. We have this negative 2 that's being multiplied. So I'm going to divide each side by negative 2. You try to add 2 there, well, take a second and think why you're not adding 2 or multiplying. Okay, so you have 4x minus 6 absolute value. 18 divided by negative 2 is negative 9. But since we divided by a negative number, we have to flip that sign. Okay, so some of you might have then, okay, well, distance away from 0 has to be less than negative 9. Okay, blah, 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 you're going, life is good. And then you come up with your 2 answers, you're thinking everything's great, you're like, oh, I understand what's going on, everything's great. But wait! You're taking the absolute value of something, and you want to get a number that's less than negative 9. Well, we remember from before that when you take the absolute value of anything, you get a positive number. So how can you sit here and take the absolute value of a number, make it positive, because that's what the absolute value does, and that number is less than negative 9. There is no x that you could put in here that would make this whole thing come out to be negative because we are taking the absolute value. So we can't take the absolute value of a number and make it less than negative 9. We can't. So here, there's no way this could happen. So our answer is no solution. Okay? There's no way we could take the absolute value of a number and get something that's less than negative 9. But Mr. Pons, yes? Let's just say that instead of a less than sign, you had a greater than sign. Well, now, we're taking the absolute value of a number, and we want it to be greater than negative 9. Bell still works. And we want it to be greater than negative 9. Well, since when we take the absolute value of a number, it's always positive, we know that any number we take the absolute value of will always be positive, thus will always be greater than negative 9. So our answer in this case would be all real numbers. So take a second and make sure you see the difference between the two. And make sure it makes sense to you. Okay? Hopefully that helped.